I'm a solutions architect at Palo Alto Networks. I'm also co-founder of a company called Acrona Security, which is focused on software composition analysis, protecting your dependencies. I am recently back in the Indianapolis area, grew up here and then spent about a decade away and just moved back. So happy to be back in the Midwest and Indiana. All right, so let's get into this. The dangers of the Python standard library. So this talk is kind of more geared towards maybe more entry-level programmers, but hopefully there's some good stuff in here for everyone to take away. All right. So first, we'll just cover what is the standard library. As Calvin said, it's kind of the batteries included modules that are shipped with Python to help developers accomplish common tasks. So when you're working with a language, you want to be able to do a lot of the kind of simple day-to-day stuff right out of the box. You don't want to have to go searching for dependencies to handle all that. And so Python makes that stuff really easy to do. Some examples might be like the OS module, so interacting with your operating system, the CSV module, working with CSV files. There's a ton more. Most of the things you want to do on a day-to-day basis are included to some degree here. Or the included bits are extensible, so you could extend those to do exactly what you want to do. So I'm kind of going to roll through a handful of kind of things you would like to avoid doing in the standard library. Then I'll cover some general Python security tips and some takeaways. So the first thing we're going to look at is assert statements. So if you're like me, you ever done much unit testing in Python, you're probably pretty familiar with the assert statement. The first security tip here is that you should never use asserts in production code because they require that the debug constant is true. So what's that mean? So debug is a constant in Python. It can be disabled. And so if you are not in 100% control of the environment that your code is executing in, you want to make extra sure that you're not doing this. If the debug constant is false, asserts just basically are not executed. So what's that look like? So this is already a really bad example of like code to write. Don't write code like this. So first we've got a hard-coded password, already a no-no. Then we've got this login function here. So just inside of this try except condition, we've got a user password that we're trying to get from the user. And then we're just basically asserting that user input equals our hard-coded password string. If so, we're going to print them a welcome. If there was some sort of failure there, we'd raise an assertion error and let them know they had the wrong password. So if you ran this in normal circumstances, it would operate just about how you would expect. If they got the password right, they'd be welcomed. If not, they would get a wrong password. However, if you run this with debug turned off, it's going to skip that line down there, the assertion line entirely, and just print out welcome. So again, just kind of a toy example, but can illustrate sort of what could happen if you were running code in an environment that you didn't control and had asserts in there to handle business conditions. So what's the solution here? The solution is, I've already said this, just never use asserts in production code. There's other paradigms that you can use there. You should also always make sure to write your checks in a fail-safe way. So if something happens that's unexpected, that you don't allow access. So always failing closed. So and over here is just, again, that simple example rewritten as an if else. So you'd want to do that check there and then give them a wrong password if they got it wrong. Moving on, the next one is string formatting. So if you're using the legacy string formatter, it is susceptible to data leakage if an attacker has the ability to modify the format string. And this one's kind of a weird one just because it's not something you see very commonly, but it is something that's good to know. It's also not quite as common these days, just with the advent of F strings gaining popularity. So the format string is that little piece, the first string there. I often call this like the template. Basically, it's the string they're going to be substituting into. So we can see here in this example, my name's Andrew, and if we printed this out, it would say, "Hello, I'm Andrew." So what can go wrong here? So we've got a little example here. Again, a hard-coded secret. So just never do that. We've got a class called animal where we will initialize and save a name variable. We then have a subclass of that called bear, which is an animal, not doing anything special there. And then we've got this print intro function. What this is going to do is going to take your string template and it's going to take an animal object and it's going to basically print out that string template with the animal object formatted into it. Next, we have a bear named Mike, and then we're going to run that function where we've got the first example printing out the animal's name and then the type of class that we're using here. So it's going to print out hi, Mike the bear. And then we can see in the second one, if you substitute the dunder class, dunder name with something like dunder init, dunder globals, all of a sudden we can see all the variables for the file here. So you can obviously leak out some implementation details, and in this case, we're leaking out a hard-coded secret there. So any variables you had defined that were accessible to globals, someone could pull out of here if they had access to that format string. A more kind of real world example, again, like I couldn't think of very many great reasons you would want to do something like this. But in this case, we've got this simple web server here. It's got a secret for some reason, and we've got a get method defined. And then this get method, basically when you call it, it's going to print out your path in part of the HTML body and then return that to you. So if I pull out of the presentation here for a second, we can see I've got this web server running. If I do hello, we get hello. If I do, bye, we get bye. It works about like you would expect. Now I'm going to actually switch over to an IDE here, and we'll see what it would look like if you were able to send something a bit more malicious that way. And the only reason I'm doing it here rather than the browser is because the browser doesn't like the formatting here. It's going to try to encode this stuff. But here we're basically passing in curl, going to that web server, and then we're sending as the path here this kind of malicious string. We're going to try to yank out those globals. And if we do that, all of a sudden we can see what we get back is we get this location inside this HTML tag here. We can see the secret is included there along with a number of other things regarding the implementation here. So again, nothing you'd ever want to do, and probably not incredibly realistic, but just something to keep in mind is that allowing users to input or modify that format string is not a good idea. All right. So what can you do to avoid this? And it's probably obvious by now, but avoid the ability for users to impact that format string at all. If you have some use case where you do want them to have access to that, you should do some sanitization checks there. Really, if you want to let them touch that formatting at all, I would be pretty strict on the sanitization. There's always fun ways to get around sanitization checks, so just be as strict as possible. And really, like the solution nowadays is probably just use F strings. Like you should try to avoid this use case whenever possible. And F strings are just a great alternative for all formatting needs. They're a lot more readable. There's just a lot of nice benefits that go along with those. So I still see tons of this legacy formatting out in the wild. Makes sense. F strings are somewhat new. But whenever writing new code, I would recommend using F strings. And if you are using the old format method, just never allow users to touch that format string. All right, the next one is going to be affecting the tar file package, and this is going to be an arbitrary file write vulnerability. So arbitrary file write is when you would extract files from an archive and the file would write into an unexpected location. So I'm sure we've all downloaded like zip files, archives from the internet. You go through, you double click that, and it extracts out to whatever directory you're located in. In tar file, it is possible that you could create a malicious tar file where when a user tries to extract that using the tar file package, that it could extract not only to your target directory, but to any other location available kind of on your host machine. And this is what some of the vulnerable code would look like. This is actually probably just straight up what the example code for this module would look like. This is like the classic way to go through and extract everything from the archive. One note before we move on is that zip file works very, very similarly to tar file, and zip file is actually not susceptible to this vulnerability. I'll share out this deck later. If you're interested, this is what it looks like to create a malicious archive. So if you're out there doing any kind of pen testing or want to test your own applications or someone else's applications, using a script like this is a nice way to easily create an archive that has some file that extracts to somewhere other than the target directory. So this one, you can just basically give it this directory level. It'll bounce back a few levels, and then you can see that your file was extracted to some higher location. So what's the solution here? Really, if your application accepts user archives and you extract them, you should always add safety checks. Since these aren't part of the standard library, these safety checks, they're kind of on you to handle. This is not a super common use case, but I have seen with some enterprise applications, especially ones where like plugins factor into them, and plugins can be added or uploaded by users. Oftentimes they're going to use a mechanism like this. And so in that case, you would want to go ahead and add those safety checks in. The other solution here is you can just very easily use a safety wrapper. I've included one here. This is a library I wrote sometime last year that does just this. It's basically supposed to be a direct drop-in for tar file, where it just literally the only thing it changes is adding those safety checks for you and spitting out an exception if it finds one of them. You can see here, the implementation looks exactly the same. It can be used in the same way in any use case for extract all or just for extract. And actually going back to this one for a second, this is definitely something that you see out in the wild. This is not a kind of vulnerability that's been highly publicized. And especially like in the Python community, you'll see that for kind of collaborative projects, that this is something out there that is accessible in the wild. I've found a number of different large kind of like machine learning projects that allow you to pull in archives. And basically they could pull something off of S3, just open it up and extract it. And if you had pointed them to something that was not so nice in S3, then they could have some file written to the hosts or the some higher up directory where you wouldn't necessarily want someone sending arbitrary files. Next, we'll look at XML parsing. So this is something we're probably all familiar with. I myself much enjoy JSON over XML, but we all have to touch it. So XML parsing in the Python standard library leaves you actually susceptible to a couple different attack vectors. The one we'll talk about today is a denial of service style attack, which is called the billion laughs attack. I'll go into more depth on that in a second. You're also susceptible to external entity expansion. I won't touch on that one as much today, but there's actually a couple different vulnerabilities lurking in Python's default XML implementation. So something to be aware of. So what's the billion laughs attack? And I guess taking a step back, what's denial of service for those of us who might not be aware of what that means? A denial of service attack would be a class of attack where an attacker would try to basically make your application unavailable to other users. So they could do that by overloading you with traffic and like a distributed denial of service attack, or in this type of attack, they're basically going to try to take control of all of your resources. So give you something so expensive to compute or parse in this case that you end up using all your memory or all your processing time just working on this one task, and other users don't have access. So the billion laughs attack takes advantage of the entity parsing in XML. We can see here, I've got this lol entity, and then I have all these other lol1, lol2, lol3 that reference kind of the higher level entities in the list. And finally, I just have this lol9 where if you expanded all of these out, you would end up getting a billion lols. So thus the billion laughs attack. So let's see what this looks like. I will switch over to another console here. All right. So we can see here, this is just a script that generates that payload I had on the other page, just a nice little function to return that. Then we have a Docker file to pull all this together. We've got a bash file here that's basically going to just execute this Python file that we'll look at in just a second, and then every second report out to us the amount of memory being used. And then this is our actual file we're using. So you can see we're pulling tree, an element tree, and then using the from string method from the standard XML library. And then we're going to pull in that function I just showed you, and then we're basically just going to try to parse it. We're not even going to try to do anything with it. But let's see how this goes. And I'm going to run this in Docker just because I don't want my computer to tip over during this presentation. So if we run it, it'll take a second. It's going to start building. So we can see here immediately, pretty large jump in memory usage here. It's going to keep growing until it hits my Docker memory limit, and it's going to tip over. But you can imagine if you had XML parsing on your website or something like that, someone sent in a payload like this for fun, that they could pretty easily knock your web server offline. Or if you had something elastic that could even scale up when memory usage was a concern, that could definitely be a big problem for you, where that memory usage is going to explode, and they could keep sending those. So what do we do about this? So what we do is we again use another kind of convenience library here. So I'm sure some of you guys have probably already heard of this, but diffused XML is a stand-in-place library for the XML library. It does just this. It kind of provides that additional safety wrapper where it's either going to ignore those elements, or it's going to raise exceptions where it finds dangerous situations in XML that you're trying to parse. Again, it operates almost the exact same way as the XML library, but with additional safety checks. So this is another good one to keep in mind. And now we'll move on to the last situation we're going to look at here, the last specific one, and that's going to be Pickle in Python. So if you're not familiar with Pickle, it is a Python library for serialization and deserialization of objects. So what that means is basically loading objects into your program or loading data into your program as an object directly, and then pickling that and saving it to disk for either saving it for a later time or making it portable to share with someone else. Basically super convenient if you've got data sets that you want to share between users or between different points in time. The issue here is that Pickle is vulnerable to arbitrary code execution when it's loading untrusted data. What this means is that if you find a dangerous pickle on the internet and you try to load it, then basically anything in that pickle could take action on your host machine, which would be very bad. It's also just really funny to talk about pickles in this dangerous sense, because most of us don't consider pickles too malicious. So this is what a bad pickle would look like. So we've got Pickle here. I'm using OS just to illustrate something you could do here. The real danger and the real key to making a pickle bomb, as I've called it here, is in that done to reduce method, where you're basically able to execute any kind of Python code you want. This done to reduce method is what Pickle and Python use to try to determine how to kind of reconstruct an object when they are parsing and loading that pickle. And so in this case, I'm just basically creating a text file named bad text file, and I'm not doing anything too bad. Below that, we're going to pickle it. So pickle dumps, and then pickling that pickle bomb. And then I'm just going to print out the raw pickle here for everyone to see kind of what that looks like. We can see that it's a bunch of hex in there. You can actually see here the touch bad file, txt. So in this case, we could tell something's going on in this pickle, but in an actual real world instance, either this pickle would be much larger, so it would not be quite as easy to pick these things out, or if you were actually going to execute an attack like that, you'd probably do some sort of obfuscation. You could base 64 encode your the riskier stuff in here. There's plenty of different ways you could hide this or otherwise make the user make it invisible to the user. So what do we do about this? Basically, just don't load untrusted pickles. So don't eat bad pickles you find on the internet. Yeah, that is what it comes down to. You could attempt to inspect the pickled objects before loading. So we saw on the last screen. You could basically inspect what's in here. You could try to parse this, figure out if there's anything bad in there. That's probably not the best approach though, just because it's going to get quite messy. Any solution's likely to be incomplete. And there's just not a real great way so far that I've seen to be able to sanitize these things in any sane way. And so what that leaves us with is kind of, if you need to load untrusted data from the internet, you should consider an alternative like JSON for your serialization or deserialization. Um, Constructs like JSON are just safer. They're more human readable. They're easier to inspect before or inspect and handle any exceptions that might arise there. And so that's kind of the alternative to go to here. Obviously, there's some pros and cons there. They're not going to be quite as convenient as Pickle, but if you have to load that untrusted data, you might have to make some trade-offs there. Here's just a list of other things that are always unsafe. So using old Python runtimes, as we all know, Python 2.7 was sunset last year. So be sure to always patch your Python runtimes and definitely avoid anything too old. If at all possible, you want to be using a somewhat modern version of Python. Yeah, there's always safety fixes in the standard releases. And a lot of other nice functionality too. So keep your Python updated. There's also some inherently unsafe functions if you're using them with untrusted input. So things like eval, exec, popen. There's a number of other ones. These are basically going to just allow anyone passing untrusted inputs into your program to take actions on your host system, which is not a good idea. So avoid any scenarios where you would be passing untrusted input into functions like that. And then finally, this one's maybe not as relevant unless you're working on something more security specific, but that is using non-cryptographic functions for security. So if you do have something that's sensitive, something that has cryptographic purposes, you should use a built-in like secrets rather than something like random. Most of us are probably familiar with random. We might not be as familiar with secrets, but going ahead and doing the learning there is worthwhile if you're trying to build something that is secure. And then finally, we've got some next steps to secure your code. So with all these things in mind, these are a few further steps that you could take. The first one is just to keep some basic application security concepts in mind. Like I mentioned earlier, that fail close or fail safe coding style. So if you encounter an exception or something like that in your login code, you always want to fail to keep the attacker out rather than let them in. Sanitizing inputs, we've looked at this one as well with some of these. Just any input you take from an untrusted source, you want to assume the worst. So putting in validation checks and sanitizing that input is always a good idea. Not using defaults, so default passwords, default configurations, these are almost never what you want to deploy to production. So for most projects nowadays, you'll see you'll see quite a difference in the configuration if you're going to deploy something to development versus production. Make sure you pay attention to those sections at the end of the documentation because they're very important and could have security ramifications. And the last one here, which you've seen me be guilty of already, is don't hard code secrets. There's lots of good alternatives here for getting around that. So just never include anything too sensitive in your files themselves. One, because we've seen ways that attackers could extract that from the code, and two, because you might accidentally commit something to a public GitHub, and then you're going to look silly in front of all of your peers. Next would be to utilize some sort of static application security testing or SAST tool. So this is going to go through, it's going to inspect your code and look for unsafe coding practices. So if you forgot any of the examples earlier, tools like Bandit would be a good start. They could catch some of these things. Bandit, if you haven't heard of it, it's a free tool, pretty widely used here to do some static analysis security testing. And it's a great start. It covers a lot of things, a lot of kind of basic Django mistakes or Flask mistakes, or just hard-coded credentials, all that kind of good stuff. It's going to protect you there. And finally, we have utilize a software composition analysis. So again, a little biased here, but I would encourage you to check out Ochrona or plenty of other tools on the market that can help you make sure that any open source dependencies you're pulling into your projects are free of vulnerabilities as well. So obviously, we all probably use open source tooling today. While we'd like to assume that's all safe, that's definitely not the case. And so you want to make sure that you are doing some due diligence there and checking the code that you're including in your projects, because it could actually end up being more volume of that code than the actual code you write. So always good to be careful about the things you import. And that's it. So yeah, thank you for your time today. Let me know if you have any questions.
Yeah, feel free to ask any questions, turn your cameras on, turn your mic on.